Hello, this time we consider a vector subspace generated by three vectors in R4, and we want to determine a number R on a parameterized vector V such that it turns out that the vector is in the given subspace. So what we're going to do here is perform a series of reductions, as in the usual sense, to equations and then systems of equations. So the first one is that we reduce this question to the consistency of a vector equation And what would that be? Well, we want to know whether we can generate with these elements here this vector v. And to do so, we establish an equation that says, okay, I want to establish a linear combination of the form x times 3 minus 5, 1, 5 plus y times 0, negative 3, 1, negative 2 plus z times 0, 0, 1, 4 equal to the vector 3, negative 8, 3, r. Of course, this translates further to a system of linear equations. So the question is now the consistency of a system of linear equations. What is that system? Well, I want to put it here, right? But it's fairly easy to detect. It's the one that is associated with each of the rows, right? So it would be 3x plus 0y plus 0z equal to 3. Next equation, negative 5x minus 3y plus 0z equal to negative 8. Next equation would be x plus y plus z equal to 3. And the last equation would be 5x minus 2y plus 4z equal to r. Right? That's the r that we're looking for. But then, well, if we examine this system carefully, right, we see that this very first equation that we have here, well, may be reduced to the following. We have 3x equal to 3. So this reduces to x equal to 1. So you may forward substitute, right, the x wherever is needed. But while doing so, right, what we're going to do is that now this 5x negative becomes negative 5. And, well, this one now reduces to the following, as we're going to see. It would be negative 5 minus 3y equal to negative 8. Of course, this is the same as to say, well, I'm going to add positive 5 on both sides of this equation, and I'll get negative 3y is equal to negative 3, which of course becomes y equal to 1. So, well, we have that other equation that we can now forward substitute into whatever is remaining. In other words, we will have something that looks like this. 1 plus 1 plus z equal to 3, which of course becomes z equal to 1. Well, we are done with this portion, right? Now let's see what this last equation that we have here can tell us, right? But that now becomes the following. 5 times 1 minus 2 times 1, which is y, plus 4 times 1 is equal to r. Well, if we add these quantities, right, we have 5 and 4, well, that is 9 minus 2, that's 7. So R must be 7. In other words, the vector V is in H, in the span of this tree, if and only if this parameter R is equal to 7. And with this, we conclude.